Good morning, all. We are going to discuss about total probability theorem. Total probability theorem. So it states that on a sample space, yes, on a sample space, yes, if we have B1, B2, B3, B4, and so on, if there are Bn events are mutually exclusive, all these are mutually exclusive such that Bm intersecting Bn is equals to pi, where m is not equal to n. M comma n are varied from 1, 2, 3, and so on up to capital M and up to capital N. Right? So this is the a sample space which consists of n mutually exclusive events. Let there is an event A is present on a sample space, something like this. Right? This is an event A. Right? This probability of A, that is P of A, can be represented in terms of conditional probability. That is, summation n is equals to 1 to capital N P of A given Bn into P of Bn. So this is what total probability theorem states. Means this total probability theorem states about what is the total probability of you know occurrence of this event A on a sample space which is which is intersected with the event B1, and this B1, B2, B3, and so on Bn are mutually exclusive events. What is the intersection point of this B2? What is the intersection point of this B3? And so on. If cumulatively added together, that is by taking summation n equal to 1 to n, then you will be getting the total probability of this event A, right? So this we need to prove. So in order to prove this, right, so we are going to consider something like, so if I add all the uh, we wanted to prove this, right? So proof, under the proof, let b1 comma b2 b3 all together are present on a sample space, right? So on a sample space, all these are b1 b2 b3, so this b1 comma b2, this b3, right, b4, and so on. How many such events? Mutually these are exclusive. If I all together add together, what you are going to get? You are going to get total sample space, right? So this expression we just wanted to write, right? So b1 union b2 union b3 union b4 union, and so on up to union bn. So if I add all together, what you are going to get? So we are going to get, this is the union that we are doing, this is the union of this is the so union, this is also union. So if I add together, what we will be getting, we will be getting a total sample space, yes, right? So this is the total sample space, yes, we can say, right? So I wanted to write a generalized expression for it, right? How can I write the generalized expression? So union n is equals to 1 to capital N, so this is b small n, which is equals to yes, right? So now, on top of which, what we are having, we are also having what do you call? So this A, event A is also present on a sample space. Right? So S intersecting A, we wanted to take that. This is in equation one. Right? So if this is the equation one, then what we are taking? We are taking A intersecting S. So what is A intersecting S? A intersecting S is equals to A we are going to get. I mean to say, so on a sample space, yes, something like this we are having. This, let us say this is an event A. Of course, this event A is intersecting with all the B1, B2, B3, and so on, Bn, mutually exclusive events, right? So this A intersecting S, we are going to get A only we are going to get, right? So A intersecting, what is S from equation 1? From equation 1, so from equation 1, what you can say? S is replaced by this union n is equals to 1, right? Union n is equals to 1 to capital N, Bn we can write, which is equals to E. Right? So now what we have to write? Now I'm taking union outside and making intersection. Right? So union n is equals to 1 to capital N. Union n is equals to 1 to capital N. Right? A intersecting B small n is equals to A. Right? So this is what, right? So this union, which I'm going to write it as a summation. Later part we can write, but apply the probability on both sides. Right? So if I apply the probability on both sides, then what we are going to get, right? Uh, let if you apply the probability on both sides. So apply the probability on both sides. So if you apply the probability on both sides, what you will be getting? So this union I'm going to replace as a summation. Summation n is equals to 1 to capital N. This union sometimes you can replace as a summation even, right? N is equals to 1 to capital N. P of A intersecting Bn is equals to P of A, right? So now if you observe this, P of A intersecting Bn is called as a joint probability. So we have discussed in previous classes, right? So this is the joint probability. As you know, joint and conditional probability both are interrelated by. So let me give you the conditional probability formula. So what is the conditional probability? So conditional probability is defined by P of A given Bn is equals to P of A intersecting Bn upon P of Bn, right? So this is what conditional probability is. Now we have A intersecting Bn with us, right? This A intersecting Bn. This A intersecting Bn, if you want, then what you can write? So P of A intersecting Bn can be replaced by P of A given Bn into P of Bn. Right? Now replace this expression, this expression in equation. Let us say this is equation 2, right? So if you replace, then what we are going to get? We are going to get as a summation n is equals to 1 to capital N. So what is that? A intersecting Bn is replaced by A given Bn into P of A given Bn into P of Bn. So which is equals to what actually? Which is nothing but P of A. This is the total probability of A, right? So now this is what the we wanted to prove, right? So finally what you can conclude, right? The total probability of A can be rewritten as summation n is equals to 1 to capital N P of A given Bn into P of Bn, you may say, right? So this is what we can say, total probability. And if you observe this, the total probability that consists is nothing but what actually, what you can see, P of A given P1. Let me decompose this, right? P of A given Bn into P of Bn, right? So if you observe this decomposition, P of A given P2 into P of B2, right? So plus and so on up to how many terms? Plus A given B capital N, last nth term you may say. So into P of Bn, right? So this is the nth term. If you observe the first term, that what we are having, A given Bn into P of B, P of B1, right? So this is nothing but individual probability of the events which are consist on a sample space Bn, B2. This is the individual probability, right? So individual probability what we are having here, and this is A given B1 means probability of occurrence of A then from B1. I mean to say the intersecting point of A. I mean to say here there is an event which is present something like this, right? So the occurrence of event A, this is an event A, right? So occurrence of event A which is intersecting with B1. This is the meaning. I mean to say probability of A from B1. So this is the contribution from B1. And this is the individual probability of B2. This is the individual probability of B2. And probability of A which intersecting with the B2. This, let us say this is B2. So this is B3 and so on. So if you combine all together, then the total probability of P of A you may get. So this is the total probability there. Thank you.